Hello class, today I'm going to be demonstrating how to dilate a triangle by a scale factor using your compass. First we will do a scale factor of 1/2, and this problem specifically says centered at point K. So we have K, L, and M, so we want all the points we want points L and M distanced for K to be halved. So the way we're going to do that is we are going to construct a perpendicular bisector by taking an arc that's more than half the distance across from K to L. And we're going to construct an arc that will intersect twice when we do it from both K and L. So this is the same arc measurement. And if I connect the intersection points here with a line, it will intersect. I'm having some issues drawing on here. Whoops, let me move that. Uh-oh. All right, so we're going to draw our first perpendicular bisector. That gives us our point, I guess we'll call it L prime, which is halfway along KL. Next, we're going to do the same thing. We're going to construct a perpendicular bisector with our compass measuring a distance that's more than halfway to M. Draw an arc. We'll take the exact same radius and place it on M and construct that arc as well. And they intersect at a point, 2 points, which we're going to use to find a point here. So now we have our 3 points. We're going to connect these 3 points of K, M prime, and L prime. And that is our triangle that measures half the size of KLM. So just to demonstrate the way that it was done by Delta Math is they actually draw an arc that's more than halfway. They take the same radius and do it from the other side. Then they connect them using a line in order to find the midpoint of the segments. They then do the same thing for KL. And once we have our 2 midpoints, we just have to construct our triangle using a ruler and line segments. Let's do a triangle that gets bigger. So this one says to multiply it by a scale factor of 2, centered at K. So the way we're going to do that is we're going to take a line and we're going to draw it from K to L and from K to J, because these lines are going to tell us how far we need to go. So first we will use our compass to find the measurement of KL. I'm just going to put an arc here. This arc is unnecessary, I just find it is useful to count how far I've moved. And this would be doubling the line segment KL to KL prime. If I wanted to triple it, I could also come over here and just do it again. That would be like a triple length. Now we're going to do the same thing for KJ. So I'm going to set my compass to the distance of KJ. Draw an arc here and draw an arc here. So now this point would be like J prime. Again, if I wanted to do triple the distance, I would have to make another arc. Now, because this problem wasn't designed to be done with triple the distance, I actually don't have access to that distance there. So let's just connect all 3 of these segments, and we should be able to see our doubled triangle. Our similar triangle that was constructed by doubling the line segment's distance from point K. Let's see if Delta Math does it differently than I do. They drew the line. They actually measured the arc to K and then just drew it onto the other side. That would double the length. So they did it slightly different than I did. But that is how you construct a dilated triangle by a factor of 2.